our task to study next type of connective tissue, tissue of internal environment. Yes, and their general structure will be different if we compare with epithelial tissue. I remind you, epithelial tissue form layers, so cells situated very close to each other. There are no space between cells. In case of the tissues of internal environment, cells situated very far from each other, they are mobile, so between cells we can see extracellular matrix, which consists of the fibers, ground substances.
قدرت هستوری
ببین وقتی میگه قدرت
we considered structure of blood as type of tissue of internal environment. Our task for the next 3 classes and today's also, we should consider other types of connective tissue. So, exclude blood, we subdivide connective tissue into the proper with special properties, embryonic, fetal, and skeletal. Today, we should consider all these. Next, our class will be devoted to studying cartilage, and last, our class will be devoted to the bone tissue. After that, you will have colloquium. And here, you can see how many different types of tissues, of connective tissue. And that's why this colloquium not so simple as first colloquium. Look please, all tissues of internal environment origin from mesenchyme have abundant extracellular matrix and separated arrangement of resident cells. So, between cells, no any intercellular junctions. Let's begin with proper connective tissue. It's difficult to explain when you parallel also is talking. Here you can see 3 types of proper connective tissue. One of them loose and 2 other dense. If we examine these photos, we can see that in case of the loose connective tissue, we can see a lot of cells with these dark points, these cells, and a lot of ground substances between fibers. This is main components of loose connective tissue. A lot of cells, a lot of ground substances, less fibers. If we examine these photos, we can see that main components here will be fibers, less cells and less ground substances. That's why we classify these tissues as dense. But if we look at the direction of collagen fibers, here they parallel to each other. Here they go in different direction. So this is too dense. We subclassify into the regular and irregular. Regular dense connective tissue can be found in ligaments, in tendon, irregular in reticular layer of the skin, for example. Loose connective tissue can be found everywhere in our organism because it accompanies all blood vessels. Blood vessels and capillaries can be found everywhere, so loose connective tissue will be everywhere. Now, step by step, let's consider their structures. This diagram of loose connective tissue, and we can see different types cells here. collagen thick and elastic thin fibers, and between space are full with round substances. Our task today to give characteristic cells, fibers and ground substances. No, this is the same but color diagrams. How look like loose connective tissue on the slide. Pole mount. This piece of the tissue was taken from cheek of rat. What how look like? A lot of cells, several fibers, and a lot of ground substances. Again. First, cells that can be found in loose connective tissue, we can subdivide into two groups or two populations. Two groups better. One group cells that can, this cell can be found in any loose connective tissue, every time. And another group, these cells can be present, can be not. So first group we name as resident. This cell obligatory present in loose connective tissue, and the second group we name as wandering. Как еще another cell? Okay, a bit later I remember. Here on this diagram you can see main cells of connective tissue that refer to first group resident. Two first cells of fibroblastic row. This is fibroblast, this fibrocytes. Actually, main function of this cell production of material of ground of extracellular matrix, as fibers as ground substances. So this cell will be present in any type of connective tissue, but we give them with different names. For example, in tendon, fibroblast, fibrocytes, we name as tendocytes. In bone tissue, osteocytes, osteoblasts. In cartilage, chondrocytes, chondroblasts. But actually, all these cells will produce extracellular matrix that will be specific for type of tissue. Next cell, macrophage. Who remembers what function of macrophage, what source of origin of this cell?
Source of origin is monocytes.
Yes, you are right. This is monocytes of the blood that leave bloodstream, enter to the tissue and perform their function. And we name this cell as macrophages. Main function of this cell, digest foreign substances, dead cells, particles, and so on. Another type of the cell here, mast cell. It's remind, according to the structure, what blood cell?
Basophil.
Yes, you are right. Basophil, because it also contains very large granules, basophilic, and actually granules contain the same substances, histamine and heparin. But now histologists in the world consider that this bit different to population, basophils and mast cell. Next cell that can be present in loose connective tissue, plasma cell. Plasma cell, this is major cell of B lymphocytes. So B lymphocytes, after differentiation, differentiate into the plasma cell, where you can see a lot of rough endoplasmic reticulum, because it produces immunoglobulins. So it's responsible for humoral immunity. Adipose cell. Here we can see one droplet of the fat flattened nuclei that displaced to the one end of the cell. And pigmental cell also can be found in loose connective tissue. Because loose connective tissue accompany blood vessel capillaries, so in loose connective tissue we can find capillaries, and you can see a general structure of such capillary. Now, the main elements of any capillary will be endothelial cells that joined with each other by junction, and they lay on the basement membrane. This gray color line, basement membrane. So, endothelium flattened cell that lay on the basement membrane in contact with each other by junction remind us what type of epithelium? Or what type tissue?
Epithelium.
Epithelium. Yes. This can be absent. Capillary consists of these two main components. Plus, time to time, in duplication of basement membrane, we can find pericytes. Pericytes we can consider as cambial elements that this cell can divide and give rise new endothelial cell, for example. And near capillaries, we also can find adventitial cell. This is precursor cell for different difference of cells of internal tissues. And look, please, adventitial cell never has basement membrane. It's important. Cells of connective tissue have no basement membrane because they are mobile. In the tissue they can travel along. Now look please at electron micrographs. But here we can see one part of fibroblast nuclear. In fibroblast we can see rough endoplasmic reticulum, Golgi apparatus, and around here, around cell, no basement membrane, it's free. And we can see collagen fibers here. This is small magnification. What these dark cells with process, with thin process, will be fibroblast. What this is fibroblast. This also, this and this. Gray color field of collagen fibers. Mast cell look like the basophil on electron micrographs, this like microscopical level, and we can see basophil on these photos, or mast cell. What is the cell, blood cell visible here?
Erythrocyte?
With nuclear erythrocytes?
No, not.
Eosinophil.
This lymphocyte.
Lymphocytes, because we can see
More
around nuclear.
Nuclear. Yes.
Plasma cell, with all these plasma cells, because we can see light portion near the nucleus that correspond Golgi apparatus, and nuclear sometimes remind us a wheel. So organization heterochromatin in plasma cell. On the light microscopic level, we can see light zone that corresponds Golgi apparatus and heterochromatin organized in this manner and remind wheel. So this characteristic of plasma cell. This as wheel. this as will, for example, again, plasma cell. Main function plasma cell, I remind you, production of immunoglobulins. Macrophages, on light microscopical level, we can see that cytoplasm has unstained parts that correspond to secondary lysosome. Other cytoplasm stained with dyes. On electron microscopical level, we can see a lot of secondary lysosome, different sizes. This is and these macrophages in the tissues, and it was used specific dyes to reveal these cells. For example, in case of this tissue, ink was injected in animal. After several days, piece of the tissue was taken and prepared slides, and cells that main function digestion digest this, absorb this ink in the cytoplasm, and particles of ink we can see in the cytoplasm. That's why what cells with ink will be macrophages. Plasma cell, look please, light part near the nucleus, and nucleus is blue. This is pigmental cell, melanocytes, and this adipose cell. Adipose cell unstained at all, because if you remember, large lipid droplet full all volume of cytoplasm, and lipid not stained with not hydrophilic properties. That's why not stained with dyes. No, this is electron micrographs of capillary endothelial cell, gray color basement membrane, and this, whereas we can see duplication basement membrane. So these pericytes surrounded by basement membrane from both sides. This is collagen fibers. Now some words about the extracellular matrix, and it consists of the fibers and ground substances. Schematically, collagen fibers, yellow color visible here. What this is, giant molecules belong to ground substances, these protoglycans. Now let's consider fibers. For example, this is collagen fibers. They can cut longitudinally, transversely. This is elements of elastic fibers. Collagen fibers on with high magnification reveal cross striation. Yes? Longitudinal section, cross section. Why? Let's consider. Not translate. Okay, I tell you because here you can understand from these diagrams what happened. When we consider synthesis of collagen by fibroblast, we can identify two phases: intracellular and extracellular. Intracellular events includes first formation RNA in the nuclear matrix. After that, using mRNA, we synthesize protein chain. After that, this protein chain undergoes modification, hydroxylation, glycalization, you can see here. And after that, three chain gather together and form triple helix. This is triple helix. We name as collagen. Pro-collagen. And pro-collagen, after that, transport into the Golgi apparatus also can modify, and using exocytosis,
Travel.
yes,
Reveals.
reveals, yes, outside. And next phase, extracellular events begins. Extracellular. Such molecule undergoes by action enzymes that cut these registration ends from collagen. What result of this you can see here. And such molecule we name as tropocollagen. After that, this tropocollagen undergoes polymerization. You can see one molecule, tropocollagen, line up with next and head to tail. This one rows. Next rows, and you can see that was gap in previous. It's overlapped by next tropocollagen molecules, and so on. And so they gather in fibril structure, and several fibrils after that form collagen fibers. Now, for example, tropocollagen, they polymerize, form fibril. Such several fibril form collagen fibers. Several collagen fibers form bundles of collagen. And alpha chain inside of the tropocollagen can differ by chemical components. And to the next type, due to difference in alpha chain, we can identify more than 25 types of collagen fibers. But for you, it's important to know only 5. Type 1 will be present in the skin, bone, tendon, cornea, the most spread. Type 2, cartilage. Type 3, this is actually reticular fibers. Type 4, they can be present in basement membrane of epithelium, and they never form fibers, they have fibril shape. And type 7, encoding fibrils in basement membrane. So 4 and 7 we can find in basement membrane, other in different type of connective tissue. Elastic fibers. Elastic fiber consists of the protein elastin and a lot of microfibril around this protein. And elastic properties you can see from this diagram. In initial state, elastic fiber have such shape. When force act, it can stretch, but after getting deformation, they return to initial state. That's why we can say about the elastic properties. Here you can see formation of elastic fiber. It begins from oxytalan fibers, where we can see a lot of microfibrils. After that, between microfibrils, protein elastin appears, and but on this stage, such fiber we name elanin, because fibrils will be situated inside, and when all fibrils will be situated only peripherally of elastin, these major elastic fibers. Ground substance. One example of giant molecule. What this is gray color molecules we name as glycosaminoglycans. Their types can be different. For example, chondroitin sulfate, keratan sulfate, keratan without sulfation, chondroitin without sulfation. So their types will be determine properties of the tissue through which molecule can diffuse or not. They allow to diffuse some molecules and stop diffusion in other molecules. All glycosaminoglycans attach to the this protein, and so all together, what all these we name as protoglycans. Protoglycans using linker protein can attach to the hyaluronic acid molecule of blue color to form so giant